Hello Unite and welcome to your very first digital lesson with me, Mr. Taylor. Just like the good old days, we're back together again, teach you some maths. What we're going to do, I'm going to make videos, I'm going to post them to Compass under each day's folder. You'll watch the video, it'll show you how to do something, and then you'll do it. So welcome, this is going to be a bit of a try, we'll see how we go. Let me know what you think, if you like it, and we're going to go from there. See you soon. So today's lesson, what we're going to do, we're going to be looking at Pythagoras still, like you started yesterday, and why. Why do we teach it? Why do we use it? Who uses it? What do they use it for? All those sort of fun things. Now, Pythagoras is the rule is really good. It's used by a lot of tradespeople, a lot of builders, engineers, construction, when they've got two sides that they know the length of, and they're trying to work out an unknown distance or unknown length, or trying to plan for what an unknown length would be. And speaking to people, it is used regularly, so it's really good if we know about it. So today we're going to look at Pythagoras like you did yesterday, but now in 3D shapes and also composite shapes. So this is the first question we're going to look at. We've got a rectangle that finishes in a triangle. That's what we mean by a composite shape. It's both got a rectangle aspect and a triangle aspect. So what we're wanting to do here is find our x, and it says to correct to 1 decimal place. So the first thing we need to do is make it into a rectangle and a triangle. And how we would do that is drawing a line across here to rule it off as a rectangle. That would then make that base of the triangle 4.2 like it is at the top. And it would also make our side of the triangle over here 2, because you'd take 5.5 minus the 3.5. So we're going to be left with 2 here and 4.2 across the base. Okay, so here's one I prepared earlier. You can see now I've got my triangle, and I'm going to try to do this and show you. Apologies for my hand in the way and shadows. So we've now got our triangle and our rectangle, but we only want to know x. Oops, my camera work's not very good. We only want to know x. So to find out x, I now have, first of all, I'm going to write my formula. A squared plus b squared equals c squared. Again, apology for the shadows, I'm doing my best. And we can say that a is the 2, so we'll substitute that in there. 4.2 squared would go in there to equal c squared, and c being our x down here. So now we've got 2 squared is 4, and 4.2 squared is 17.64 equals c squared. So all I've done is I've substituted the numbers into the formula here, squared them down here, and now we're going to continue to solve it. So 4 plus 17.64, 21.64. And remember, you can use your calculator for all of this as well. We're then going to need to find the square root of both sides, which leaves us with c equals 4.65. And because the question asks for 1 decimal place, we're going to write x equals 4.7. And there's our first answer. This next question is a bit different, because we want to find out the area of this shape, but we don't know the height. We can't use the half base times height formula, because we don't know the height here. So that's the first thing we're going to need to work out. So if we make that a right angle triangle, we know here that the base would be 9, and we've got 15 over here for our hypotenuse. Okay, so we're now substituting our numbers in. We've got a, which we're going to make is 9, so 9 squared plus b squared, and then our c squared is the 15. So 15 squared. Solving that equation, we're going to make it 81 plus b squared equals 225. Now we need to do a linear equation. We need to get our unknown on its own. So we've got a minus 81 to both sides. Leaves us with b squared equals 144. Now to find b, we need to square root both sides. Thankfully, 144 is a friendly number, and that's going to make us have b equals 12. So we now know the height of our triangle over here is 12 millimetres. Knowing that, we can now work out the area. Half base times height. So half, our base is 18 for this whole triangle, and our height is 12. Solving that gives us an area of 108 millimetres squared. So all I did there was I put into the calculator 18 times 12 divided by 2, and that gave me 108 millimetres squared. I've got 0.5, and I've got 1.801, and I've got x. 0.5. Oh, sorry, I should write my formula first. Always write your formulas, ladies and gentlemen. 0.5 squared plus 1.801 squared equals c squared. Okay, that's going to give me, not what I want. No it does, I lied. So we know that 1.801 squared is 3.25. We just did that before. That's easy. 3.25. And we've got 0.5 squared equaling 0.25. Add them together and we get 3.5 equals c squared. Square root them both. C equals 1.87 metres. To 2 decimal places. And then we know that up here, x is 1.87 metres. So, again, we use the same formula we've been using this whole time. A squared, b squared, c squared. 1 squared plus 1.5 squared equals c squared. Obviously 1 squared is 1, 1.5 squared is 2.25 equals c squared. C squared then equals 3.25. To get the square root of that, key it into your calculator. And you should get around 1.8001. Alright, so there is my y value up here. So the base of this triangle in here is 1.801. What we're now going to do, we're now going to work out the triangle up the top here to get x. So we're going to get this line to find x. So if I draw that, the last thing I want to show you today is Pythagoras in 3D. We've got a 3D shape here, and we want to work out what z, y, and x is. Firstly, I can tell what z is over here because it's the same as the 0.5 there. So there's my first little bit done and dusted. But I need to work out what y is in order to be able to work out what x is. So the first thing I'm going to do is I'm going to use this triangle here at the base. So the line over there, which I know is also 1 metre. I'm going to use the base down here, which I know is 1.5, the same as there. And I want to find that line across there. So what that triangle would look like is that 1 metre, 1.5 metres, and y. So that concludes the 3 things that I want you to learn from today's lesson. You'll be able to watch those videos over and over. Hopefully they are good enough for you to make sense. I have just done this sitting on my couch at 9 o'clock the night before. But I think it's a pretty good solution. Hopefully it helps you out. I will get your feedback on that Friday. And I'll probably do some more for Friday's class as well. And what I've now done, I've had a look in your textbook, decided on some questions you should do, and the teacher taking you should be able to give you those. Good work, guys. Look forward to seeing you next time. Bye.